the one you did in the lecture, but I think I'm just, yes, setting up the integrals wrong in chapter 6.
6, number 13?
Mm-hmm.
6.13. A man and a woman agreed to meet at a certain location about 12:30 p.m. If the man arrives at a time uniformly distributed between 12:15 and 12:45, and if the woman independently arrives at a time uniformly distributed between 12 and 1, find the probability that the first to arrive waits no longer than 5 minutes. What is the probability that the man arrives first? Okay. So, how did you set this one up? Or how did you try to set it up?
Yeah, so for the first part, the whole, like, the 5-minute thing, that's very similar to the one you did in class, like in the video. So, I mean, I said, like, so let's use, like, X to represent the man and Y to represent the woman.
Okay.
And so then, for the case where I'm trying to
So
think through,
X is uniformly distributed as?
Yeah, uniform distribution between, so I said basically between, like, 12.25. 12 point. Does it matter, like, if we have 12 versus, like, if we go from, like, 0 to 1 versus, like, 12 to 13?
No,
Like,
not
that,
really.
Okay.
That
I
won't
just didn't
matter
know
at
if that
all.
was part of what was messing me up. So yeah, and then Y is uniformly distributed between 12 and basically 13 in this case.
Yeah.
If we're,
Right.
so in the one where the woman arrives, wait. No, in the one where the man arrives first, you've got the integral from 12.25 to 12.75, and then the integral from x to x plus basically a 12 dy dx. But then it was the other case where I was confusing myself. So I don't know if that makes sense.
Okay, yeah. So are you able to write down a joint density for these?
I guess not.
Huh?
I'm confused. I'm sorry.
So what's the density for X?
Oh, it's 1 over 12.75 minus 12.25. Yeah.
Which is 2.
Yep.
And that's for X between these two things.
Yeah.
0 otherwise.
0 otherwise.
Okay. Okay.
And that's just going to be 1 if we're between 12 and 13, and 0 otherwise.
Okay, and what is the joint density going to be for these two? Since they're independent.
Oh, it's just going to be the joint density of x times, I mean, the density of x times the density of y.
Right, it's going to be the product of the marginals.
Okay.
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 So, yeah. So what does that give us?
That gives us 2 if we're between 12.25 and 12.75 and 0 otherwise, right?
Well, but
No.
it's a pair of things, right?
Right. Okay.
So okay. So what's going to happen here? Yes, it is equal to 2 if what's going on?
If x is between 12.25 and 12.75 and y is between 12 and 13.
Yes.
Okay.
Okay. So it's equal to 2 if x is between, right, 12.25 is equal to, or is less than x, is less than 12.75. And if y is between 12 and 13, yeah. And is there anything else going on here? I don't think so, because if x is like outside of this range, if x is outside of this range, then the marginal for x is 0, right? Okay. And what if y is outside of the range from 12 to 13? Well, that's going to be 0. Yeah. So I think it's just 0 elsewhere. Yeah. And I mean, you could kind of think about, look, if I'm in, so essentially the graph of this thing looks like this. And again, it's sort of artificial. So that here's x, here's y. It's sort of artificial to have, and this is z. It's artificial to have like the 12, 13 thing, but whatever, right?
Mhm.
So let's see here. Maybe, this is going to be a totally distorted graph, but
Mhm.
here's 12 and 13. And maybe over here, well, maybe I'll put 12 and 13 here as well. But the reality is I don't really care about 12 and 13. All I care about is, 12.25 and 12.75. Okay. Getting obsessed with my colors here. Okay, so this is the range of x and y that I really care about right here. Okay. And what is the base length of this? Isn't this like, this is a half unit, right?
Mhm.
And what's the width of this thing? Isn't that just 1? Yeah. And if I were to draw the actual surface here, this thing would be how high?
2.
Yeah. That's right. So the height of this thing is 2. And lo and behold, guess what? The volume of that, what's the volume?
1.
Yeah, the volume is 1, which is good news for us. Okay. Now it's just a matter of making good use of this density.
Okay.
Okay, so how are we going to do it, Katie?
So we'll need to do a couple integrals depending on who gets there first, right?
Okay, so right. So okay, so let's see here. Um, what's the probability that the man arrives first? How do I write that? So it'd be the probability. Can we do that one first? X. That would be the probability that x is less than y, right?
Mhm.
And how would you set that up? Well, it's going to be a double integral, right, over the set where x is smaller than y. Yeah.
Mhm.
Of what? Of f of xy dA. And how would we set that up? What do you guys think? Maybe it would be easier. Here, let's go over to the next page here. Maybe it would be easier to kind of think about what's happening in the xy plane. So here's x and here's y. What did we say? Where's x between 12 point, right? So that, look, I don't know, here's 12 and 13 or something. And y is 12 and 13. But x, I really only care about being between 12.25 and 12.75. Okay. Right, so that's the critical range of x and y, right?
Mhm.
There.
Mhm.
I only care about, if I want to ask, okay, what about x less than y? When does that happen? Well, um, you know, x less than y. So there's the point 12, 12. Here's the point 13, 13. It seems to me that, like, so here's the line. Here's the line y equal to x. Do you see what I'm saying?
Mhm.
And so wouldn't that be like basically integrating over this region right here or something like that? Yeah.
Mhm.
Okay. So, seems to me that, okay, what's going to have to happen? It looks, look, it's going to be a mess if you try to let y go between a couple of values, okay? What seems to be the easiest thing to do is to let x simply travel between 12.25 and 13, yeah? Or and sorry, 12.25 and what?
12.7.
75.
Cool.
And then as that's happening, so if I take an arbitrary x value in here, what does y travel between? Always. So if I take this arbitrary x value here, what is y always traveling between?
X and 13.
Yeah. So y is, you know, bigger than x and less than 13. Does that make sense?
Mhm.
So what's the probability that x is going to be less than y? Well, now that we have a better understanding of what's happening here, and by the way, we're obviously in the range where the density is equal to 2.
Mhm.
So it's going to be the integral from 12.25 to 12.75. And that's dx. That's what x is going between. And it's going to be the integral from x to 13 dy. And what are we integrating? Isn't it just the constant 2,
Mhm.
right? Does that make sense?
Yeah. Yeah.
All right, so what's that? That's going to be, right, I can factor out 2, the integral from 12.25 to 12.75. The antiderivative of 1 is just y, so it's just going to be 13 minus x dx. That should be a pretty straightforward integral, right? What Okay, so we'll kind of leave that one there. But what about the other problem? What was the other one?
Um, the probability that the first to arrive waits no longer than 5 minutes.
The probability that the first to arrive waits no longer than 5 minutes. Okay, and of course, 5 minutes is equal to, I have to talk in terms of hours here, don't I?
Mm-hmm.
That's like 1/12 of an hour. Okay. So what's it going to be? How would you set this up? It's kind of like the one I did in the lecture, right?
Mm-hmm.
So how would we do it?
Well, I guess this was the one I was more confused on, just because, yeah, it just varies depending on who gets there first.
So find the probability that the first to arrive waits no longer than 5 minutes. Well, wouldn't that just be the probability? Okay, if X arrives first, okay,
Mm-hmm.
X would be less than Y, but you don't want X to be, so the man arrives first, then the woman arrives, but you want them to arrive within 5 minutes. So you would want this to be smaller than what?
X plus the 12?
Yeah. Okay, but that's not the only situation, right?
Mm-hmm.
The other one would be the probability that what?
Y is less than X is less than Y plus 12?
Yeah. I think the one thing that's maybe a little bit different about this one than perhaps the example I did in the lecture, was the example I did in the lecture completely symmetrical?
I think so.
Like that there was the same distribute, like the arrival time was the same for
Mm-hmm.
X as it was for Y in terms of the uniformity.
Yeah, I
Was
think
that
so.
true? So this one's slightly different, right? So I can't quite just say that the one is twice the other.
Right.
Okay. I really do have to kind of do each one of these. Okay, so let's think about this first one. The probability that X is less than Y is less than X plus a 12th. Huh. Well, what do you think?
Well, for this one, it seems like we ought to just be able to let X range anywhere from 12.25 to 12.75, and then let Y range anywhere from X to X plus 12.
Okay, because you don't run into any danger of like
Right.
the end of the thing.
Right. It's the other one that I'm less, yeah, I'm not really sure what's happening with that one.
Okay, so let's think about that carefully. So
Mhm.
so we have 12.25 and 12.75, right? And we have 12 and 13 for Y.
Mhm.
Okay. So this is the critical box right here. Okay, I'm gonna put like there's 12 and there's 13 just for good measure. Okay, so this guy, so in 13. So you have the line Y equal to X coming through right here, right?
Mhm.
This is the same picture we had before. Okay, X less than Y less than X plus a 12. X less than Y less than X plus a 12th. Well, one thing that we know is like this point right here. Oh man, I mean, my picture is not looking very good right now. But what height is that at? What height is this supposed to be at, apparently?
12.75.
Yeah. Which is really, I mean, if you, right, so this is 12:45, right?
Mm-hmm.
And if I add 5 minutes to that, I'm still going to be below 13. Does that make sense?
Mm-hmm.
So in this particular case, let me kind of draw this in red. Y would travel between, would be like in this little parallelogram right here, and it would be a completed parallelogram, right? Okay. I wouldn't like bump up into the ceiling of possible Y values for this one. Right, so I think that you're exactly right. X could just run wild between 12.25 and 12.75. And then as that's going on, what would Y go between?
X and X plus a 12.
Yeah, because, right, so whatever X is, Y starts on the line Y equal to X, or just above it, and then goes up to this line right here, which is the line Y equal to X plus a 12th. Yeah.
Mm-hmm.
And I simply am not going to like bump through the top of this thing. Okay, so yes, it's going to be from X to X plus a 12th of 2 dy dx. Yeah?
Mm-hmm.
Oh man. Hey, isn't this going to work out like super nice? Because the antiderivative of 2 is just 2y, right?
Mm-hmm.
And you plug in X plus a 12th and you plug in X and you take the difference and the X just cancels, right?
Yeah.
We can actually compute this fairly easily. It's just going to be 12.25, 12.75, 2 times a 12th. So isn't that just a sixth,
Mm-hmm.
the X? And of course, if you integrate a constant, it's just going to be the length of the interval times that constant. So this ends up being a sixth times a half or something, right?
Mm-hmm.
Which is a 12th. Okay. Now the other one is the one that seems to be a little bit more taxing, I think. So what's going on there? What if we want to compute the probability that Y, so the woman arrives first and the man arrives no more than 5 minutes later. Okay, so what's the picture going to look like here? Okay, here's X, here's Y. Okay, so here's Y equal to X. Okay. So, all right, so here's 12. I'm just going to do this. So 12 and 13, and I'll fix this in a minute. And 12 and 13. Okay. So you have that and that. But the actual box itself, right? So if I were to just kind of draw the entire box, it would look like this. But the critical range is not that, right? It goes from 12.25 to 12.75. It's this. Okay. And what's going on here? What am I interested in? I want the stuff between x equal to y. I want the stuff between x equal to, so the two lines I'm interested in here are y equal to x and y equal to x minus a 12th, right?
Mhm.
So this line is going to be critical to us, but so is that minus a 12th. Is that going to be a problem? So like what? Okay, so hang on, let me highlight something here. What about this point right here? What is this point? What point is that?
12.25, 12.25.
Yeah, right. Right, and this is 12.25 in this direction.
Mhm.
I minus, so that's like 12.15, right?
Mhm.
So it seems like if I go down by 5 minutes, I think this whole thing is still going to fit in here, isn't it? Do you see what I'm saying?
Mhm.
So right here, I'm 12.15. If I go down by 5 minutes, you know, from that, I think I'm going to get this thing. So wait, did these end up being the same?
To get the answer in the back of the book, they should be. I'm just confused on why.
But now we see it, right? Now we see it because think about it. So x, you know, because this is the line. This is the line y equal to x minus a 12th, right?
Mhm.
And the only place I would have to worry about potentially bumping off the bottom of the purple region, which is the region I'm interested in,
Mhm.
is at the very leftmost endpoint, 12.25, yeah?
Mhm.
But if I subtract 5 minutes from 12.25, so basically 5 minutes from 12.15, that's only 12.10. You understand what I'm saying? Which is still above 12. So this thing is still above 12 here.
Okay.
So how am I going to integrate this thing? What x value should I go between? To make sure I intercept this whole region right here, right? Which, by the way, means, you know, I mean, so x between y and y plus a 12th, okay? Isn't that the same thing? I mean, doesn't that correspond to what I've drawn right here? Isn't that true? No. Am I drawing something wrong? So y, okay, so if y is less than x is less than y plus a 12th, right? Then the lower limit of this thing is y equal to x. And the upper limit of this thing is y equal to x minus a 12th. Okay.
Mhm.
So y, X.
So are we going to be flipping the order of integration on this integral from the other one? Like, so the other one we did dy dx. On this one, are we going to do dx dy?
I don't know. I think that's what I'm trying to decide because the way I drew the picture, unless I drew it wrongly, I think it's like actually easier to just do x first.
Okay.
Um, is equal to y. Y plus a 12. I'm pretty, I mean, I can't discern anything that's wrong with this picture. I just don't go down below this bottom portion right here. You know what I'm saying? So it seems to me that like I can almost do the exact same thing that we did in the last part.
Mm-hmm.
And x is just going to go from where to where?
Y to y plus 12.
Uh, yeah, well, x, well, x is going to go, well, man, what is, so hang on a sec. So y, hmm. Just to go between y and y plus a 12. Hang on a second. And maybe this is different. Okay, so hang on a second. So if y is going between 12 and 13, okay, so if I take like a y value between 12 and 13, so here's a y value between 12 and 13, then x starts on the line, right? Y equal to x, and it goes up and it increases until it hits this other line. Does that make sense? But that happens until when? So actually, maybe this parallelogram is slightly off from what I had hoped. Okay, so hang on, I'm gonna draw this thing. Let me draw it in green so that you can see it. So it's like this. Okay, so if y is 12, x goes from y equal x over to here, yeah? And then it goes, and then if y increases, it keeps going, okay, until this thing right here. Okay. But the problem is I still have, so look, you're going to have this nice little parallelogram thing right here. But then it seems to me that, okay, and what point does that happen at? Think about it for a second. Oh, wait, I actually no. What am I drawing here? This thing has to stop when? When can X, where does X have to stop?
12.75.
Yeah, okay. So look, I have to, man, let me erase some of this stuff. Okay. So I think that what happens is eventually, so like once you get to this point right here, stuff starts changing for X. Okay. So once you get to this point right here, which by the way is at 12.75, stuff starts to change. Okay, so I have this where X is constantly going between Y, or X, X equal to Y and X equal to Y plus a 12th, right? So X is like constantly going between those things. And then what starts to happen from that point on? Do I get anything else? I mean, think about it. Once Y is equal to 12.75, what happens? So look, I have this little purple sector right here. But once Y is equal to 12.75, I mean, what in the world is going on? Can X even be beyond that anymore? Can X ever be beyond 12.75?
No.
No, that's 0. So actually, it is this nice parallelogram right here. Everything works nicely. So what's going to happen is Y is going to travel between, because once Y gets beyond 12.75, we get no contribution to the probability at all. Okay? So where am I going to integrate in Y? What value is Y going to go between? Y starts at
12.75.
12 and it goes up to where? 12 up to 12.75. Yeah? Because think about it, X can't be beyond 12.75, yeah? I mean, that's what this picture is kind of showing.
So why can we start at 12? Because X can't be smaller than 12.25.
Oh, I see what you mean. Okay. So yeah, here, that picture is getting messed up there. Can I just redraw this down here? Okay, so what do I have here? I have 12.25 and I have 12.75, right?
Mhm.
And then what about X, or what about Y? It's like 12 and 13, right?
Mhm.
Okay, so this is the critical range for X and Y. Okay, and what are we saying? Okay, so 12, 12 is going to be basically right here, and 13, 13 is basically going to be right here. Okay, so this is the line Y equal to X. Okay, And then what's the other line we're concerned about? So this is the line y equal to x. And what's the other line we're concerned about?
Y equal to x minus a 12.
Y equal to x minus a 12th. And isn't that line kind of like, it's not right? So this point right here is below that line, yeah? That's what we were kind of saying.
Mm-hmm.
So this is y equal to x minus a 12th. Okay, and so, yeah. So if y is equal to 12, we don't get this whole thing, do we? If y is equal to 12, interesting. If y is equal to 12, do we get anything at all? Because what's 12 plus a 12th? So if y is equal to 12, then what we're saying is x needs to be between 12 and what? What's 12 plus a 12th? 1205?
Mm-hmm.
Is that even possible?
Mm-hmm.
When's the first time that we actually get something? What's like the lower limit of y before we start getting something, I guess?
12, 15,
Well,
12, 20.
12:15. So hang on a second. So
Oh,
we need to go up by like 5 minutes, correct?
yeah.
So if y, okay, so 12:10 less than x less than 12:15. That's where we kind of start to get something. Once y is past 12:10 p.m., we start to get a range of x that actually makes sense for us. Okay. So if y, so like what's the lower limit of what y could possibly be? What's 12:10? What does that actually mean? Isn't that just 12 and a sixth? Okay. So the first time we actually get something is when y is at 12 and 1/6. Okay. Because then we're going to actually start getting some x values. Okay. And so that's if y is equal to 12 and a sixth. Okay. It's equal to 12 and a sixth. I think that it's going to be 12. So 12 and a sixth to 12.25. I think x, okay, 12 and a sixth to like 12.25. That's when we get this little thing down here. We get this little nipped off corner right here. X is always going to be traveling between, right? We get this little tiny triangle sitting right here. Okay. X is always going to be traveling between 12.25 and what is it? Y is equal to, was it x minus a 12th or something like that? Or y plus a 12th? x equal to y plus a 12th, basically. Okay. So I think that what's happening is when y is between 12 and a sixth and 12 and a quarter, you end up getting x just going from its smallest possible value to that other line. But then I think for everything else, let's see. Okay, so this is probably like 2 dx dy plus what? Then how high can y actually get before we run out of room? How high can y actually get so that we'll still get a contribution from x? What's the largest that y could be? What do you think?
Basically 1240. That would be what, 12 and 2/3? No, wait. Yeah. That could be wrong.
So I think it's just so you said, what did you say?
I said 1240, but now I'm thinking about that and I'm not sure that's right. So
1240. Because if y is equal to 1245, then we're not going to get any contribution from x, which is why you're saying 1240.
right, but I do think we can get closer to 1245.
Yeah. So, I mean, yeah, oh man, this is kind of a mess. So you could go integral. Okay, so what? So 12.25. What's 1240?
I think it's 12 and 2/3.
Right, to 12 and 2/3. Okay. And for all those things, x can just travel between y and y plus 12. Or not 12. What do I mean? Not 12. Y plus what?
At 12.
Okay, and that's going to be 2 dx dy. Okay, but then what happens?
We're gonna have one other like little nipped off corner piece we're gonna have to deal with.
Oh man, that's horrible. Okay, so then it's going to be the integral from 12 and 2/3 to where?
12.75.
12.75. Is that it? Is it 12.75? I guess it is, right? Yeah. And what is the innermost integral going to be? Isn't x going to just go from y to where?
12.75.
To 12.75, yeah. Woo, man. Okay. So apparently that, are you serious? So hang on. So it's going to be like a nipped off. It's going to be nipped off. Yeah. That's so weird. Apparently that integral is you're telling me that that's just equal to what?
In theory, a 12.
What? Are you serious?
Well, the answer in the back of the book was a sixth, and we already have a 12th. So.
Okay. Well, now I'm pretty curious. I might go over here real quick and actually do this. So what is it? Okay, what do I want to do? I want to integrate 2. I want to integrate the function 2 from where to where? 12 and 1/6 is like, isn't 6 times 12, 73 over 6? Okay. Let's go x going from 12 to, well, hang on. So y going from 12 to 6, which is 73 over 6. And it goes up to 12.25. Okay, and then I think you can go x traveling between 12.25 and y plus a 12th. Will it understand this thing? Did it do what I wanted? I think it did.
Yeah.
Right? Okay, so therefore, it understood what I was saying. That's a good thing. Okay, maybe I can just add this to it again. But this time I'm going to go from y goes from 12.25 to somewhere else. Where does it go to? It was 12 and 2/3, right?
Mhm.
Which is 38/3. And x was going from y to y plus 12. Okay. Plus, okay, what was the last one? What was the last one?
Y is going between 12 and 2/3.
12 and 2/3. That's the same as 38/3, right? And where?
12.75.
Yeah. And x was going between y and something.
12.75 also.
We all pray that it's a 12th. Oh man, that looks like it might be a 12th. Is it? Yes, it's a 12th. Okay, so I think it's a 12th. In fact, I think I think I could have asked it for an exact result or something. What on earth? There's got to be. I'll have to think about this. There's got to be an easier way to pull that.
There was.
What's the easier way?
This was the one I was talking to you about in office hours one day.
Oh, okay.
You can basically just integrate from x to 12.25 to 12.75, where y goes between x minus a 12th and x plus a 12th.
Oh.
Oh, and that gets you the whole thing?
Yeah.
Oh, that's me.
Yeah, that kind of makes sense. Is that what I told you to do before?
No. So I was asking why I couldn't just basically switch the integration around, and I think you came up with something like this. I was working in minutes though, and so, but yeah, and you basically said that you would never want to integrate this way.
Which I just did.
Yeah.
Sorry. Well, that was a good exercise in and trying to think about how to do integration in multiple variables. Yeah. Yeah. Well, maybe I'll kind of I'll actually write something down and post a little video of a simpler way to proceed. But we got it, right? Sorry. Hey, thanks for asking though. Yeah. Well, thanks guys. Have a good afternoon.
Thanks, Dr. Hammock.
But I'll try to sort out an easier way to do this, and I'll post a short little video. Hopefully it'll be short. Hopefully it won't be like 45 minutes or something like that. But yeah, it's a worthwhile exploration nonetheless. But we got the right answer, so that's good. All right. Sorry I didn't come up with a more elegant solution than that. All right. Hey, have a good day, guys. I got to go to another class right now.
Bye.
Thank you.
All right. See ya.